Right now, something unsettling is happening beneath the coastlines of the United States. It isn't loud. It isn't dramatic. Most people don't feel it at all. But deep beneath the land and offshore, the ground is quietly shifting in ways that have scientists paying very close attention. Over the past year, clusters of earthquakes have appeared in places that rarely see them. Offshore sensors have recorded subtle changes along major fault zones. Satellite data shows sections of coastline slowly rising, sinking, and tilting by just a few centimeters. To the public, these movements are invisible. To geologists, they are signals. The United States is often thought of as geologically stable compared to places like Japan or Indonesia. But that sense of safety is misleading. The United States coastline is not a single system. It is a patchwork of tectonic boundaries, ancient faults, offshore subduction zones, and slowly awakening structures that stretch from Alaska to California, from the Pacific Northwest to the Caribbean, and from the Atlantic seaboard to the Gulf of Mexico. Many of those systems are under growing stress. Earthquakes are not evenly distributed across time. They cluster. Pressure builds silently for decades or centuries, then releases suddenly. What concerns scientists today isn't just individual earthquakes. It's the patterns forming beneath America's coasts. Patterns that suggest the ground is adjusting, redistributing strain, and preparing for changes that could reshape entire regions. To understand why the United States coastline faces serious danger, you have to step back and see the bigger picture. Because this story doesn't begin on the beach. It begins deep inside the Earth. The western edge of the United States sits on one of the most active tectonic boundaries on Earth. Here, the Pacific Plate is grinding past the North American Plate, moving northwest at nearly 2 inches per year. That motion does not stop. It does not slow down. And it does not release stress evenly. Most people associate this boundary with California and the San Andreas Fault, but the reality is far more complex. The San Andreas is only one piece of a massive fault network that extends offshore, inland, and beneath major cities. Every year, this slow plate motion transfers energy into dozens of interconnected faults. Some creep quietly, others lock up completely, and when locked faults finally break, they release energy in seconds that has been accumulating for centuries. But California is only part of the story. To the north, the tectonic situation becomes even more dangerous. Stretching from Northern California through Oregon and Washington and up into British Columbia lies the Cascadia Subduction Zone. It is one of the most powerful and least understood fault systems on the planet. Here, the Juan de Fuca Plate is diving beneath the North American Plate. Unlike the San Andreas, this is a subduction zone capable of producing massive megathrust earthquakes. Geological evidence shows that Cascadia produces magnitude 9 earthquakes roughly every 300 to 600 years. The last one struck in January 1700, long before modern instruments existed. But its fingerprints remain. Coastal forests suddenly submerged, tsunami deposits found inland. Japanese records describe an orphan tsunami arriving with no local earthquake. Today, Cascadia is locked. GPS measurements show that the coastline is being slowly dragged westward as the offshore plate pulls it down. Stress is building, and when it releases, it will do so violently. A full rupture could send shaking from Northern California to British Columbia. Coastal towns would experience minutes of intense ground motion. Offshore, the seafloor would snap upward, displacing massive volumes of water and sending a tsunami racing toward the Pacific Northwest coastline. Some communities would have less than 20 minutes to react. What makes Cascadia especially dangerous is not just the size of the earthquake it can produce. It is how quiet it has been. Long silence in tectonics is not comforting. It is a warning. Along California's coastline, the danger doesn't come from a single fault. It comes from a tangled web. Offshore faults run parallel to the coast, hidden beneath the ocean floor. Some are extensions of known systems, others are poorly mapped or only recently discovered. Earthquakes here can generate strong shaking and localized tsunamis without warning. In Southern California, faults beneath Los Angeles and offshore near Santa Barbara pose particular concern. The region's geology is compressed and twisted, creating blind thrust faults that don't break the surface but can produce devastating earthquakes. The 1994 Northridge earthquake came from one of these hidden faults. It struck without warning and caused billions in damage. Similar structures exist beneath coastal cities today, and as stress shifts along the Pacific to North American boundary, earthquakes don't always strike where scientists expect. Pressure can jump sideways, triggering rupture on adjacent faults. This makes forecasting specific locations extremely difficult, but the risk is real, and it is growing. Far to the north, Alaska experiences more earthquakes than the rest of the United States combined. This is where the Pacific Plate plunges beneath the North American Plate at a steep angle, forming the Alaska Aleutian Subduction Zone. This system has already produced some of the largest earthquakes ever recorded, including the 1964 Great Alaska Earthquake, a magnitude 9.2 event. Today, multiple segments of this subduction zone are once again locked. Offshore sensors show deformation along the seafloor. Inland GPS stations record steady strain accumulation. When earthquakes strike here, they do not stay local. Tsunamis generated in Alaska can cross the Pacific, affecting coastlines as far away as Hawaii, California, and even Asia. Beneath southern Alaska, deep earthquakes indicate movement far below the crust. These deep events may be transferring stress upward, setting the stage for future ruptures closer to the surface. Compared to the West Coast, the eastern United States feels stable. Earthquakes are rare. Faults are ancient. The land appears quiet. But this calm is deceptive. The East Coast sits on old, cold, rigid crust. When earthquakes do occur here, seismic waves travel farther and with less energy loss. This means even moderate earthquakes can be felt across multiple states. The 2011 Virginia earthquake, a magnitude 5.8 event, was felt from Georgia to Canada. It damaged buildings in Washington, D.C. over 80 miles away. Along the Atlantic coastline, buried faults left over from ancient continental collisions still exist. Most are inactive, some are not. Recent seismic studies have identified zones of weakness beneath coastal cities like Charleston, South Carolina. Charleston experienced a devastating earthquake in 1886. That event caused widespread destruction long before modern development filled the coastline. Today, those same areas are far more populated. Along the Gulf of Mexico, the threat is different, but no less serious. Here, the danger is not just earthquakes. It is land subsidence, salt tectonics, and buried faults destabilized by natural processes and human activity. Large portions of Louisiana and Texas are sinking. Sediment compaction, fluid withdrawal, and natural fault movement are lowering the land relative to sea level. This amplifies the impact of storm surge, flooding, and ground instability. While major earthquakes are less common here, smaller seismic events are increasing in some areas, particularly near offshore energy infrastructure. These movements may not be catastrophic on their own, but they weaken the ground and stress existing faults. When combined with hurricanes and rising seas, the Gulf Coast faces a compound threat that unfolds quietly until disaster strikes. Hawaii sits in a unique geological setting. It is not near a plate boundary, but above a powerful mantle hotspot. As volcanoes grow, they become unstable. Massive portions of their flanks slowly slide toward the ocean, driven by gravity and magma movement. These slow motions generate earthquakes. Occasionally, those movements accelerate. Geological evidence shows that parts of Hawaiian volcanoes have collapsed into the sea in the past, generating massive tsunamis. While rare, the risk is real. Modern instruments show that some volcanic flanks are still moving. Small earthquakes cluster along these zones, indicating ongoing instability. Across the United States, scientists are detecting subtle but important changes. Satellite measurements reveal coastal deformation in parts of California, Alaska, and the Pacific Northwest. Seafloor sensors record strain along offshore faults. Micro-earthquakes cluster in places that do not match historical patterns. Artificial intelligence systems now analyze real-time seismic data from thousands of sensors. These systems do not predict earthquakes, but they do identify anomalies. They highlight areas where stress is accumulating faster than expected, and patterns that resemble the early stages of past large events. Several regions now stand out: Cascadia, Southern California, parts of Alaska, and offshore fault zones previously considered low risk. None of this means a major earthquake is imminent tomorrow, but it does mean the tectonic system is active. Activity often precedes change. One of the hardest truths in seismology is this: earthquakes rarely happen where people expect them most. Stress does not respect borders or assumptions. It migrates. It accumulates in silence. And when it releases, it often does so along faults that have not moved in centuries. Sometimes earthquakes occur on faults that were not even known to exist until after the rupture. This is especially true along coastlines, where faults can be buried beneath sediment, water, and human development. The United States coastline is not static. It is alive. The same forces that created its mountains, bays, and islands are still at work today. Plates continue to move, crust continues to bend, pressure continues to build. Earthquakes are not signs that the land is failing. They are signs that it is adjusting, but adjustment can be violent. As coastal populations grow and infrastructure expands, the consequences of major seismic events increase. Ports, bridges, power plants, and cities sit directly above active geological systems. Understanding those systems does not prevent earthquakes, but it does give people time. Context, awareness. And awareness is the first step toward resilience. The signals are there. The movement is ongoing. The pressure is real. The only unanswered question is where the next major rupture will occur. Will it be Cascadia, releasing centuries of locked energy? Will it be California's coastal faults, hidden beneath the sea? Will it be Alaska, once again reshaping the Pacific Rim? Or will it be a fault most people have never heard of? One thing is certain: the United States coastlines are not as stable as they appear. The ground beneath them is shifting, and the forces shaping the future are already in motion.